Now, whenever you are solving a question in GATE, in examination hall, and you find that question paper is lengthy. Question paper is lengthy means the length of the question also can be very long to read, very long sentences, big table, big diagrams, as well as you are feeling that the solution that you are doing, that also is requiring many steps to solve, many calculation to get to the answer, which makes the overall paper lengthy. In recent GATE 2024, this was one of the common feedbacks that I have got, that questions were very lengthy. Questions are so lengthy that right now I am discussing, suppose, a memory based question, so students do not even remember properly because of the length of the question, that what were the details of the question. If there was a problem of industrial of simplex, so what were the all data given, obviously it's not easy to remember that. So that's why at this point of time we have been only able to see 3-4 lengthy questions. But yes, I have got this feedback from almost everyone that paper was lengthier than usual in both the senses. Both the senses means length of the question was also there. Students were telling me that they had to scroll. If this is the screen, if this is the screen of the monitor of the computer, and this was the question palette here, and this was the question here. So entire question with the diagram or with the table was not visible at once. They had to scroll up and down to read the question, then see the table, then see the diagram, then read the question. So I can understand this is not a very comfortable situation. Even simple question can become complicated and difficult in such situation. And obviously the question also were not very easy. I am not saying they were very difficult or super hard, but they were also not very easy. Level of question was moderate, slightly higher than moderate, but given the exam situation, given the pressure and given length of the question, I can definitely say that there were some of such question where you would have felt the heat, felt the trouble. What is the point that I am trying to convey here? The point that I am trying to convey here is that if you are solving the question in an exam hall and you are feeling that paper is lengthy, maybe questions are lengthy or the process you are feeling is lengthy, you have to make sure that you don't just start solving quickly. You have read the question, you took time, but you don't start solving it suddenly and quickly without thinking about the approach. Because in mechanical engineering, I will talk only about mechanical engineering, there are more than one ways to answer a question. Some of the ways can be very lengthy and some of the ways can be very less time consuming, very short. And one of that concept and one of that question I am going to discuss today, where if you choose the wrong, I won't say wrong, but lengthy approach, you will have to do 4-5 steps to get the answer, and those 4-5 steps have lot more chances of mistake. But if you choose the right approach or the fastest approach, in less than a minute, in less than 60 seconds, yes, even less than that, you will be able to get the answer without any mistake. So it is important that this is a learning for you from this, that don't just start solving the question. I can agree that question can be lengthy, but solution, there are ways to do it in lesser time, to do it faster. Whether that clicks you in exam hall or it doesn't click you in exam hall, that's a separate thing. It is possible that if there are 2-3 ways to solve a question, in exam hall it may not click to you ki yaar, what was the shortest way, what was the fastest way. It may happen. That's why it is important to practice to build numerical solving skills. So let's discuss one of such question. So this is the question that we are about to discuss, which was asked in GATE 2023 Mechanical Engineering. At this point of time, when I am discussing this question, it is a memory based question, which means actual language of the question and the data points given in the question may be slightly different than this one. But overall, this is the concept. This is what the question was. and the process also and the learning also is going to be absolutely valid, what I am going to do. So as I was telling you, there are multiple ways to solve and a very interesting learning for all of you from this explanation that I am about to give. It says that in a shell and tube heat exchanger which has single shell and 20,000 tubes. We all know how shell and tube heat exchanger works, right? So obviously we are going to draw a schematic diagram, a simple diagram of this, not the real construction, because 20,000 tubes we are not going to draw. So a very simple schematic diagram of shell and tube heat exchanger is this one, right? Now it further says that in the shell steam condenses at 50 degree Celsius. So this is the shell side, the bigger one, right? There phase change is occurring. So it's a special case situation where phase change is occurring, right? Whenever you have condensation or boiling. So that's a special situation in heat exchangers. We know 2-3 things changes accordingly. So that temperature is 50 degree, means this temperature at inlet as well as at the outlet for the shell is going to be 50 degree because it is condensing. And also because it is condensing means this is the hot fluid, right? The hot fluid condenses. If it is phase change with the boiling, then what's going to happen? The cold fluid is going to evaporate. So you have to be very careful about these small things, that when something condenses, when it comes in contact with a cooler medium, right, then it condenses. And when it comes in contact with hotter medium, then it has a tendency to evaporate, obviously after reaching the boiling point. So this is very much important in heat exchanger to identify the hot and the cool fluid. Accordingly, you know what all expression changes and everything, right? We have discussed all those things. So if you make some silly mistake in identifying the hot or cool fluid, then obviously it's difficult to get the right answer. So here it is condensing, so it is the hot fluid. So this is the TH in, TH out, both 50 because heat change is occurring. And at what rate is it flowing through the heat exchanger is also given to you, mass flow rate of steam. Now water, specific heat is given of water, 4 kilojoule per kg Kelvin, enters the tube at 30 degree. So water is entering the tube at 30 degree. So temperature in for the cool fluid is given to you. Obviously from temperature also you can get the idea, right? This is 30 degree lesser temperature fluid. This is 50 high temperature fluid. So it is entering at 30 degree and flows at a rate of 1 kg per second through each tube. So from one tube it is flowing at a rate of 1 kg per second, and there are 20,000 tubes. So total mass flow rate is going to be 20,000 of the cool fluid, right? So mass flow rate of the cool fluid is going to be 20,000 kg per second. Small mistake, but if some of you missed multiplying 20,000, then obviously you are gone. Through each tube, if the latent heat of condensation is 2.3 to 6 megajoule per kg. Now this is talking about the shell side or the steam which is condensing, right? Because if there is phase change occurring, latent heat will be required. If there is no phase change and there is some sensible heat exchange going on, then temperature will change. So it will give you the value of the specific heat, right? We know these things. So for the phase change side, for the shell side, for the steam side, latent heat of condensation is given, value is given megajoule per kg. Again, a small thing to note, this is in kilojoule, this is in megajoule. While solving, you have to be careful. So find out the effectiveness of heat exchanger. How much is going to be effectiveness of heat exchanger? Whatever is the data given here, let's summarize that here in this diagram. I'll remind you here that for the questions of heat exchanger, it is highly recommended either you draw the diagram or you draw the graph, right? Graph, I'm going to show you in one of the methods. You will be able to recall what I'm talking about, but draw either of these. It will help prevent some silly mistakes in the calculation of temperature or temperature differences. So this is what the diagram is, simple diagram. Temperatures I have written 50-50, this is 30. Mass flow rate for cool side is going to be 20,000 multiplied by 1 kg per second. Specific heat for the cool side for the water is given 4 kilojoule per kg. Per kg Kelvin should be there, per kg Kelvin, right? So Kelvin is missing from here. It will be Kelvin also, per kg Kelvin, correct? Now, for the hot side, how much is the mass flow rate? That is also given to us, 430 kg per second. And now for the hot side, we don't have the value of specific heat, we have the latent heat of vaporization because it's a phase change, or latent heat of condensation because it is phase change. So that latent heat, specific latent heat is given to us, which we have written here. So this is the given data in front of us. Now, as I was telling you, there are 3 ways to solve this question. Let us discuss the fastest, quickest and the best way to get the answer. We know that effectiveness is given by rate of actual heat transfer divided by rate of maximum heat transfer, right? Q actual by Q max. Q actual by Q max. That's the most basic definition, most basic expression of effectiveness. Further, we have even more complicated expressions, right? We'll come to that also. But this is the most basic one, correct? Now, how much is the actual heat transfer going on here? Do you know that value? Do you know the value of actual heat transfer? There are multiple ways to find that out, right? That you can find out either by mc delta T for the cool side or for the hot side. Can you use this expression here? Delta T is not known for cool side, so you cannot use this expression. And for that side, you can't use this expression. For the shell side, for the hot side, you cannot use this expression. Why? Because phase change is occurring now, so there you have to use this expression, right? Actual rate of heat transfer is equal to mass flow rate multiplied by latent heat. This expression you can apply because for the hot side you have been given mass flow rate as well as latent heat. You multiply them, you will get the actual heat transfer, right? How much is the heat being transferred from the steam to this liquid, fluid, water, right? You multiply them, you will get the actual value. This is basically the multiplication of m dot L. What about the maximum heat transfer? Again, we know that expression, that is equal to C min multiplied by delta T max. C min multiplied by delta T max. And what is the value of C min here? If you notice here, any time in any question, there is one side where phase change is occurring. There is one side for which phase change is occurring. For that phase change, how much is the value of specific heat? If you want to define, it is very, very high, right? We tend to write it, for the sake of discussion, we tend to write it as infinite. Why? Because for a fraction of second, it can take a lot of heat, still its temperature will not change because its phase is changing. So the amount of heat required to change the temperature is practically infinite, right? Theoretically infinite. So this is the value of C for phase change. So whenever phase change is occurring, the value of C for that fluid is always C max, because it tends to infinity. That is why the other side, the cooler side here, whatever is the value of C for that is going to become C min. Right? Again, something which we already know, which we have discussed, that why this value of C is going to be higher. Whenever phase change is occurring, the value of C for that medium is going to be infinite. That is always going to be C max. So C min is going to be the other fluid which is in contact with the fluid where phase change is occurring. Here phase change is occurring on hot side, so cool side is going to be the C min. That C min value is equal to Cc, which we know. And what about delta T max? Delta T max is just the highest and the lowest temperature in the entire heat exchanger. Do we know that? Yes, we know that. How? Maximum temperature is 50 degree. Even if this cool fluid is getting heated up, it can never become more than 50 degree. We know that, right? So this temperature will be less than 50 degree only. So in a way we know that this is going to be less than 50 degree. This 50 cannot be challenged. This is the maximum temperature. This will be more clear to you if just in case you quickly draw this graph. In one of the method I will discuss that. This is 50 degree, this is entering at 30 degree, this temperature is not known to us. So maximum is 50 and the minimum temperature is 30. C in is always minimum, this is always minimum, right? So what's going to happen? Basically we know of all the things in this expression, we know the value, every value we know, right? So here just expanded, this is the heat capacity, I've expanded that into mass flow rate and specific heat capacity. If you put the value of mass flow rate, latent heat, again small point about latent heat value was given to us in megajoule, right? But this C value is in kilojoule. So you multiply that with 1000 so that units are consistent. This value, this unit will become kilojoule per kg. So both of them can get cancelled. So that's why this value is equal to 2326 kilojoule per kg. This is what I have written because this unit and this unit, they will cancel out, right? So this is the numerator. In the denominator, mass flow rate of cool side, tube side 20,000, C value is 4, delta T max, maximum temperature 50, minimum was 30. Solve it. This is your answer. Now, I took a lot of time. Does not mean you have to take such time, right? I am explaining everything to you, na? You don't have to explain the solution in exam hall to anyone, right? You have to just solve it, think and solve. If you apply this expression, reaching from here to here is not going to take you more than a minute. Even if you do it very slowly, carefully, within a minute you will be able to get the answer. But I'll show you one approach, method number 3. This was method number 1, na? Method number 3 has so many steps. I'm sure some of the students would have done that because in exam pressure it is possible that you are not able to think clearly, you are not able to pause for 10-15 seconds, 30 seconds and think which approach is better, right? It may happen. So those students would have wasted a lot of time. Anyway, coming to the second method, and before coming to the second method, I am not explaining anything. I'll just show something to you that we have already discussed, and while talking about this in the course, I clearly said it's a numerical tip. It will save your time in the exam hall. So even if this method 1 did not click to you in exam hall, method number 2 should definitely cross your mind because this is something which I specifically mentioned and specifically taught, saying that it will help you in numericals. If you know the temperatures, if you know all the temperatures, it's going to be extremely easy to get the value of effectiveness, right? I'm not going to explain this, I've already done that, but I showed you 2 cases. If Cc is equal to C min, means cool side is the minimum specific heat side. This was case 1. Another was if hot side was C min side. These 2 cases were covered, right? So for that case, this is what eventually the expression of effectiveness was coming out to be, right? Just put the value of max and actual, this will cancel out, right? Again, I'm not explaining this, I'm sure you know. So this is the expression of effectiveness. I'm sure you remembered this. I asked you to note it down in your notes. And in this one, if you notice, everything is known other than TC out. Only TC out is the unknown thing. The rest all are known. And is it a very difficult thing to find TC out? You know the heat transfer, right? You know the heat transfer. How much is the heat transfer? M dot L, you know, right? How much is the heat which is coming from hot side to the cool side? So if you know the total heat which cool side is receiving, just do the MC delta T. For the cool side, you know the mass flow rate, you know the C, you know the inlet temperature. Find out the outlet temperature, MC delta T is equal to the total heat that it is receiving, which is M dot L. You will simply in one step here to find out TC out, simply equate the heat of cool and hot side. Hot side, it is M dot L, cool side, it is MC delta T, right? And there only T out is unknown. In the entire expression, TC out is unknown, everything is known to us. Just put the value and solve, you will get TC out. And this TC out you have to put back, where? In this expression of effectiveness that I just told, this expression, right? Where only TC out was unknown, rest all things were known to us, right? Minimum cold side temperature was 30, maximum was 50, hot side temperature inlet 50. Only this was unknown. This we calculated by heat balance, by energy balance. So upon solving, you are going to get the same answer 0.625, which we got from the method number 1. Same. Here only difference is that it will require you 2 steps. Step number 1 would be to find out TC out, and step number 2 would be to use this expression. Only one extra step. This is also doable in less than 2 minutes, I'll say. Again, if you remember the formula, this will also take less than a minute, but you may have to think through. So let's say you will take 2 minutes, less than 2 minutes to get the answer of this one. Now comes the most blunder method to answer this. It will get you to the answer. Please understand, whatever methods are going to exist, they are going to get you to the answer. But if in exam hall in 3 hours you were able to solve 60 questions, 55 questions, but now if you are using wrong approach, if you are using lengthy approach, you are able to solve 45 questions, let's say. You have not solved anything incorrectly, but your attempt have decreased a lot, right? You are losing marks. Losing marks does not always mean to do a question incorrectly. It also means that you chose the longer methods, you chose the complicated ways to reach the answer, which not only takes more time but also has chances of mistake. More calculations, more mistakes possible. Right or not? So the effectiveness, you may think, ki chalo, I'll use the formula of effectiveness, where NTU method comes. Remember NTU method, where we use the formula of effectiveness. And for this case, you don't have to bother about parallel flow or counter flow, because it's phase change. For phase change, for both the cases, this is the formula, right? But if you decided to go by this method, it will increase the time that you will have to spend by 300 to 400%. So here, to find out effectiveness, you have to find out NTU, right? To find out NTU, this is the expression. You know C min, but you don't know UA value, overall heat transfer coefficient and surface area. Individually, you can't calculate. Product, you can calculate. How to calculate product? That you can calculate from the expression of heat transfer, right? So to find out this value, you have to find out heat transfer. Actually, heat transfer is equal to UAS LMTD. To find out UAS, from this expression, you know this, you know Q actual, not a problem. But you don't know LMTD. Now you have to find out LMTD. To find out LMTD, what you have to do? This diagram we have drawn, this graph we have drawn, hot side, cool side, temperature increasing from 30 to 42.5. This calculation you have to do. This calculation you have to do. So this step, what we did here, na? Where has that gone? Temperature, yeah, this step. That also is one step which is there in method 3. You have to find out TC out, because without the temperatures, all the temperatures, you cannot find out LMTD. So you are finding out this temperature also. This is also one more step. And that temperature then is known to us, 42.5. Now you are in a state to find out LMTD. That also is going to be tricky. You will start getting confused for whether I should use delta T1 of parallel or counter flow. Answer will come same from both, but that's added confusion. So you will find out the value, you will put the values here. Obviously it has a lot more calculation. Now you have found out this expression of LMTD. And now this expression of LMTD you will put here. From that you will find UAS. That UAS you will put here. From that you will find NTU. That NTU you will put here. From that you will find effectiveness. So 1, 2, 3 step, 4 step and 5th step was this 42.5 calculation. So 5 steps are there to reach the answer. That too have chance of confusion, silly mistake or definitely calculation mistake. And compare that with method 1, 1 step. Method 2, only 2 steps. This is why method is important. It's not always about getting to the answer, jaise taise karke, I have just solved the question. It can work for you out of the exam hall, but in exam, it is definitely not a good thing. So what is the learning from this? That always try to develop your numerical solving abilities. Always try to think about what are the different ways in which a question can be solved, a shorter way in which question can be solved. Even if the first method did not click, in exam hall, this method definitely should click, because this was discussed and specifically mentioned that this formula you have to use. Imagine, so easy. If you know all temperatures, effectiveness you can easily calculate. And if you paid attention, if you note down in your notes this formula, then you would have realized that only one temperature is required. Yeah, I know this temperature, and this temperature. Only one temperature is required, and I can find out effectiveness in one step. How can I find that out? Oh, I can equate heat, na? The most basic expression, most basic in heat exchanger, which is true for all heat exchangers, parallel, counter, phase change, whatever type of heat exchanger is there, heat balance, energy balance. QH is equal to QC. If you do that, quickly you will get this. All temperatures are known. In one step, find out the effectiveness. So these are the things which, even after knowing, if you are so much in flow of exam, pressure of exam, that you are not able to think which way is correct, so that's not a good thing. That's what you have to focus on developing.